So growing up in Uganda, we all know agriculture is a very important sector now for both our economy and the livelihoods of different people. We've been able to observe that there has been an increasing decline in the soil fertility, and this has compelled many farmers to use inorganic fertilizers to increase productivity. However, most farmers buy fertilizer as advised on the local market, and even when they're applying it, the quantities they use, it's not something that's informed based on what is present in their soil. And this has caused a lot of problems to do with their yields. It's also caused a number of environmental issues, especially soil and water contamination. So it's because of that that we came up with an innovation, the Mark Agrometer, which is an NPK-based and also soil moisture-based testing device. It's able to detect the soil moisture content and also the NPK values in the farmer's field. And this helps them to inform what type of fertilizer they buy and also what amounts they apply to their fields. Soil testing particularly is expensive, and oftentimes it's only in the urban areas. So we came up with this handheld device where a farmer is able to test their soil there and then at their farm without having to travel. And it's something that is not expensive to use. So they're able to know what exactly their soil needs in terms of the fertilizers. So the next time a farmer has to go buy these fertilizers, it's actually an informed decision. As you can see, it has a screen, then it has these buttons, and then there's this sensor probe. So this is what the farmer takes and inserts into the soil. What you do is you insert it near the root zone of the plant. And then here on your screen, you're going to get feedback of what's happening in your soil. On this sensor, they show you that it takes moisture, it takes pH, it takes nitrogen, phosphorus, potassium readings. So for us, what we're using it for is for only moisture and NPK. That's nitrogen, potassium, and phosphorus. So when you put it there in the soil, it's going to give you feedback. You're going to see how moist your soil is, then you're going to see what percentage of nitrogen you have, what percentage of potassium and phosphorus.
We also want to integrate the system of calculating. So if it has detected that this is the percentage of nitrogen, this is how much phosphorus is there, how much potassium, we want in the database to compare. If you are talking about, for example, a maize crop, we know that maize crop probably wants 100 kilograms of nitrogen per hectare. But if we have already in the root zone maybe 50, that means we need to add the other. But this information is always not there, the farmer. Also in terms of moisture, we want to sort of detect and say if it is falling below the requirement of the crop, then it should send information that you need to add water, you need to irrigate if it is not going to rain, for example, in the next 2 or so days. So this is the idea. So in brief, we have the soil moisture sensor integrated with nutrient sensor and then packaged into a system that also has what we are calling a fertilizer application rate calculator. So it is that calculator that now puts things together and then communicates to the farmer.
This project started earlier this year, and we were given funds by MACRIF, that's Macquarie University Research and Innovations Fund. And then we collaborated with the Department of Agriculture Production and the Department of Agriculture and Biosystems Engineering to implement it. We've done tests on small scale and on large scale. We've done some tests at Kabanyoro. That's where most of our projects go to be tested to see if they work. And then we've also tested with some farmers to verify that we are not the only ones that are using the thing, and it's not only working for us. The materials used to make this Mark Agrometer are sourced locally on the Ugandan market. Apart from this NPK probe that we usually have to import, and it becomes the most expensive item on this entire kit. So we've had a few challenges, especially with limited funding. because from our few community outreaches, a number of farmers have actually requested to have this device, but we've had challenges with mass production in order to meet the demand out there. And also, one of our future prospects for this innovation is that we have a shift from having a manual user guide to a phone application that would be able to take data that is read from this sensor, integrate it with data from about the different crops that the farmer has and the growth stages, and give the farmer an overall decision right there on their mobile phone on where to source the fertilizer from, in what quantity.